All right, y'all, I'm back. Mr. Collins, now we're going to be passing through the middle third of all the review material, starting back at the very, very beginning. So if you pass through a second time, this should be solidifying the information in your head. These should be getting easier as we get through this whole entire review. And if, again, you get through the entire review, having done another third, my claim is you're pretty darn close to being perfectly ready for the exam. Let's get to it. So this is where we're back to page 1. This is asking us to identify angle relationships for the angle pairs given. Please note that these lines are not parallel. Okay? So the relationships we're looking for are not going to be congruent or supplementary. We're looking for names like corresponding, alternate exterior, et cetera, et cetera. Okay, so let's get to it. So 4 and 6. Here we have 4, here we have 6. They're both trapped between the lines. That's going to make them interior. They're both to the right of the transversal, and so we're going to call these same side, not alternate. Come on, Mr. Collins, that's crazy. And we're going to call these same side interior, okay? Because they're both on the right side of the transversal. They're in between the two lines. Looking at 4 and 5. 4 and 5 are also trapped between the two lines, but they're on either side of the transversal. So these are going to be alternate interior angles. Okay. 2 and 7, well, 2's here, 7's here. They're definitely outside the two lines, so they're exterior. One's on the left, one's on the right. We're going to call these alternate exterior. Okay. 2 and 3, let's check those out. Oh, 2 and 3 are right here. They're trying to trick us. 2 and 3, we don't need any special name from this. They're across each other at an intersection, so these are going to be vertical. 3 and 7, so 3 and 7. One's in, one's out, so we can't call them interior or exterior, but they're both on the left-hand side of the transversal, so they're both kind of left and down. That's a signal for corresponding. Okay. And finally, we have 1 and we have 6. So here is 1, here is 1, here is 6. Well, 1 is like left and up. 6 is like up and right. These have no special relationship. Okay. Not even friend-zoned. These things don't even have any relationship. Okay, let's move on to the second page. Maybe if my mouse works. There it is. Okay, second page, we're doing some algebraic relationships with two lines. Remember, the big difference here is that we see that we have parallels. And so since we have parallels, we can definitely claim a stronger relationship. If we notice where these angles are, they're trapped between the two lines, but on either side of the transversal, so they're going to be alternate interior angles. By definition, those are congruent, which means we have two angle values the same as each other. In this case, we have 8x minus 10, and we have 5x plus 5. So you know what time it is? It's algebra time. So let's get all the x's to one side first. So let's get rid of the positive 5x's. Okay, so when we divide out the 3's, that's going to leave us a nice x value of 5. All right, we should definitely double check our numbers, right? So let's bring it back to original diagram. We have 8x minus 10. The x value is 5. So we have 8 times 5 minus 10. That's going to be 30 degrees. Okay, so let's check that. 5 times 5 plus 5. Look at that, 30 degrees. We know we're correct. Now, sometimes the test questions will not require you to do that last step. I'm not going to require it either, but I'll tell you what, it's going to be a good thing if you do. At least give you a clear sense if you're right or wrong. All right, let's look at this example. It's a little more complex because we're dealing with a shape. But what you should know all the way around, we have parallel lines. And so if we have parallel lines, then we definitely have two lines cut by a transversal. We're in business. And so we have this blue set of lines. Now, the reason I'm picking those out instead of maybe going the other direction right now is because I'm noticing I have two angles that touch this transversal at the top. and they also both have x in them. And that's important because if we're going to interact variables, they should be the same variable. If you turn your head to the right, like cock your head to the right, you can see those angles are going to be in between the two blue lines, and they're going to be below the green transversal. So they're going to be same side interior angles. By definition, same side interior angles are supplementary. I'm going to abbreviate, which means I'm going to add things together to get 180 degrees. In this particular case, it's going to be the two angles that the transversal touches. And so we're looking at 10x minus 50 and 3x plus 35. Okay, so 13x. So we have negative 50 plus 35. That's going to be minus 15. Okay. Now I'm leaving my space because I know I have to solve for y in a second, so I'm going to leave myself a little bit of space here. So let's compactly finish this problem. Let's add 15 to both sides. Okay, so we have 13x's, the same as 195. Divide both by 13. Okay, we have x is equal to 15. That kind of messed up, so I'm going to rewrite it here. So x is equal to 15. There we go. Let's double check. Let's throw those into our values. So 10x minus 50 turns into 10 times 15 minus 50. That's going to be 100. Remember, the relationship here is supplementary, so 3 times 15 plus 35, please be 80. And it is. Look at that. We are correct. Always feels good to be right. Now, that does give us different options to solve for y, because now we know some actual hard values. Okay? So we know for a fact, if we look at the other transversal, this transversal, I know that this value has to be 80, because then I have two parallel lines cut by transversal. We have same side interior. I know this has to be 100 degrees. I know that for a fact. Okay? But I'm not going to take advantage of that right now. I'm going to point out that we still have same side interiors. We still have two angles that add together to make 180 degrees, 10y plus 5 plus 25y minus 87.5 to equal 180. So I just want to practice actually solving this bad boy out, okay? So we have a lot of cleanup to do here. 10y, 25y, that's going to be 35y's. Okay. We have 5 minus 87.5. So we have minus 82.5. Okay, so if we add the 82.5 to both sides, we got something real gnarly. So we got 35 y's are the same as 262.5. Divide the 35's out. We have y to be 7.5. Don't be afraid of decimals. They're part of mathematics. We can't avoid them. Let's make sure that we're right. So let's come back to our diagram. So 10y plus 5 turns into 10 times 7.5 plus 5. That is going to be 80, confirmed. I feel good about this. So 25 times 7.5 minus 87.5 is going to be 100. So we're confirmed that's going to be correct. Okay? So don't be afraid of decimals. They're part of math. So just because you get a decimal doesn't mean you're wrong. Double check your work. Let's do one more in the set. No, this is the last one in the set. Okay, so let's go end this video here. So this will resume in the middle part of the next page where we're talking about proving lines are parallel.